Okay, these are the topics that will be discussed in this video. We'll cover the different control statements. Each control statement contains at least one clause. Think about this as how the statements are structured. We'll also focus on indentation of Python code using these control statements. And finally, we'll see how these control statements can work together. In Python, code is executed in sequential order like we see in this example. There are 8 lines of code, and the output is presented underneath line 8. It is possible to control what code is executed based on certain values in logic through statement types. This is where control statements come into play. Control statements in Python is a way to execute certain pieces of code in your script. There are different control statement types that you could use that will have the program run portions of code based on stated logic. These statement types are coded to make decisions and will know which code it would need to execute first. Control statements are considered to be compound statements, meaning these statement types contain multiple lines of code. Here, we have an example of one control statement known as the if statement, shown in lines 1 through 4. A string variable is defined in line 1, then in line 3. The if statement checks to see if MIS is part of the course variable. The colon at the end signifies that there's more code that will follow that belongs as part of the if statement in line 3. Here are some other control statement types using 2 higher level categories to differentiate between them. Selection statements contain different if statement structures, which will be covered shortly. There are 2 repetition statements that involve looping through a block of code. As you will see, these are very powerful tools in programming. Various built-in functions that you've used so far have these type of statements running behind the scenes. Each control statement serves a different purpose and makes use of built-in keywords in Python. If statements use conditional statements to assess whether or not to execute certain blocks of code. A for statement assesses each value inside a sequence, such as a list or a dictionary, and performs an action on it one at a time. A while statement repeats the same action over and over as long as the stated condition is true. Here's a table that consists of Python's built-in keywords. We will not be working with all of them, but definitely most of them. Keywords in Python have different color fonts in your editor or in your console. You cannot use these keywords as variable names in your code, and certain keywords only work with certain statement types. Let's take a look at the first control statement. So here is a general description of the if statement clause. It's important to understand that each of these statement types contain a header as well as a body that is called a suite. The header uses the if keyword and is followed by a condition that is ended with a colon symbol. You'll notice when you enter the if statement header in your Python console or editor, the next line of code will be automatically indented. All code that is indented after the header is considered to be the body of the code that will execute if the condition in the header is true. Keep in mind that the general syntax describing how the if statement or other control statements work will vary from one source to another. For example, you might see the general syntax describing the if statement like this on your right. Essentially, this is the same thing. Keep in mind that an expression is a statement that needs to be evaluated, such as 2 plus 2, or determining if a value in a variable is greater than another value. Keep in mind that the general syntax describing how the if statement or other control statements work will vary from one source to another. For example, you might see the general syntax describing the if statement like this on your right. Essentially, this is the same thing. Keep in mind that an expression is a statement that needs to be evaluated, such as 2 plus 2, or determining if a value in a variable is greater than another value. A clause consists of a header as well as a suite. The header is that first statement that is followed by the Python keyword, and the suite is that body of code underneath the header that's indented. In this example, we have code from an editor that shows code in lines 16 to 20. The header in the if statement clause, shown in line 19, evaluates if the grades variable is greater than or equal to 73. This will result in a Boolean value of true. As a result, the program will execute the suite in the if statement, which is a print statement displaying pass. Here's an example of an if-else statement. This is similar to the simple if statement example, but now an else clause is included. The else clause contains a header with the keyword else, followed by a colon. There are no other statements or expressions that are included in this line. The body of code underneath the header will execute if the condition in the if clause is not true. In this example, grade contains a value that is less than 73. The program will first check the condition in the if statement's header. And since the condition is not true, it will go to the else clause and execute the body of code in there. All code that needs to be executed in the else clause must be indented. You can guess what the output in this code would be. Here's another example of an if-else statement along with its pseudocode. Pseudocode is a way to describe how to code the algorithm in English terms. The structure of the pseudocode could help you get an idea of what to code and what would need to be indented as well. Here is another example of an if-else statement when the Python keyword in is used as part of the if statement. The in keyword is considered to be a membership operator. Here, the if statement uses the in keyword to check if characters MIS is in the course variable. Since course contains the string value MIS433, the if clause is executed. Another extension of the if statement is the if-elif else statement. This is used when there are multiple cases to test for. For example, let's say that we would like to display a letter grade based on a known number grade. Here's an example of the pseudocode along with the syntax of how you would code this. This type of statement allows only one if and one else clause, but allows for multiple elif clauses depending on how many cases or conditions to test for. The code here contains two elif statements. The clause in line 5 is executed because the condition in the elif header is true. With this type of if statement, only the suite for the first true condition will execute. So in other words, the program will go through each header to evaluate the condition until it results in a true value. Afterwards, the code inside that condition will be executed, and then the control statement is ended. It is possible to achieve the same result using several if statements instead of using the clause elif. However, this will require the program to check each condition even after a true case is found. It may not be the best approach if you're dealing with a large programming script. Your code should be written as efficiently as possible. As a reminder, each clause contains a header and a body. The body is also known as a suite, and it must be indented. This is the block of code that will be executed based on a condition. Here is an example where the else clause contains a print statement that is not indented, causing the program to output an error. Anytime you encounter an error, pay attention to the error type, research the error further online, and work on a solution through trial and error. Sometimes the error is clear enough that you'll know exactly what you need to do. In this example, we have an else clause that contains two print statements. Line 7 is indented, whereas line 8 is not. When executing this code, the output will always include the words retake the course, even with a passing grade value. This is because the print statement in line 8 is not indented, making it a line of code that will always execute as part of the program. If it is part of the if-else statement, then it will need to be indented as part of the else suite. Here is a before and after comparison. On the right, the else suite contains the two lines of code correctly. Okay, let's take a look at our first repetition statement called the for loop, or the for statement. There is an else clause in a for statement, but it's often not exercised, and we will not be using it in this course. The for statement performs the specified action for each item in a sequence. This control statement contains a built-in iterator, meaning it has the functionality to go through each item in a sequence one at a time. The for clause contains a header with two keywords highlighted in blue in this slide. The header will include a colon at the end followed by the body. All lines of code within the body of this statement must be indented. This statement begins using the for keyword followed by a variable that could be given any name, which will be referred to in the body of this for statement. After this variable, the keyword in is included, and finally the sequence to focus on. The sequence can be types such as lists, dictionaries, and strings. These sequence types are considered to be iterable types, meaning that each item or element in the sequence can be analyzed one at a time. To really understand repeated statements like this one, the concept of iteration must be understood. In Python, we have variables, also referred to as objects, that consist of data types such as a list. Certain types of objects, like those that have indexes, are considered to be a sequence that can be analyzed one element at a time. The process of analyzing one element in the iterable object is called an iteration. Python has a built-in iterator function that works behind the scenes when using a for statement. Let's take a look at some examples. Here's an example of a for statement where in line 1 it starts off with a course variable being defined, and then in line 3 it contains the header of the for statement, which will be assessing each item in a sequence. And in this case, it happens to be a set of string values, MIS433. The body of this for statement contains a print function that will apply the string method lower. This string method converts uppercase letters to lowercase letters. Since our string variable contains numbers as well, the for statement will still iterate on these numbers, but will not be impacted or modified. You'll see here that we have the output MIS in lowercase along with the numbers 433. The output, however, shows each character in the string printed on a separate line. The sequence values could be included within the header of the for statement, or it could be referred to as a variable as long as that variable is defined prior to the for statement, like the previous example. Any variable that will be referred to inside the for statement must be defined prior to calling the variable. Here's an example where in line 1, the total variable is defined with the value of 0 assigned to it. This is called initialization. The variable total is initialized with an integer value type because of the value assigned to it. Line 3 contains a list that will be iterated on. Line 4 contains the code that will be evaluated. Here, the total variable will contain the cumulative sum of values in the list. The example on the right is pretty much identical to the example on the left, but uses what we call an augmented assignment statement. Notice the difference in how the expression is written. Again, this is pretty much the same thing. It's just a shortcut way of writing the expression. The for statement in this example contains a list type sequence that is stored in a variable named gradeList. Line 4 contains the header of the for statement, which includes the gradeList variable. This gradeList variable is considered an iterable variable. The body of this repetition statement begins in line 5 and includes an expression that sums the total of grades. The total is stored in a variable that is defined in line 2. The end result is the total sum of grades in the sequence. The steps involved here are as follows. The first grade in the list is 100. This grade will be added to the total, which was initialized to 0 prior to the for statement. The total variable stores the sum, which is now the value 100. Then the next grade will be iterated on, which happens to be the value 80. This will be added to the total, and in memory, the total is currently a 100 value. The total will be updated by adding 100 plus 80, and then it will repeat. It will iterate until the very last element within that sequence. It's important to note here that the print statement is not executed in the suite because it is not indented, meaning it is not part of that for statement clause. It will execute once the for statement iterates on each grade. Once that is done, the print function will be executed. Try running this code yourself and see what happens. Afterwards, indent the print function and run the code and examine the difference. Here are two other examples of the same code, but the only difference is how the print function is positioned in line 6. This code may be a lot to take in right now, so it will be a good idea to copy this code in your editor and mess around with it. In this code, the course list variable is defined and a course string variable is initialized by using two double quotes. This means anything stored in the variable, in this variable, will contain string values only. The for statement is executed, followed by the suite containing the concatenation of two strings, but the item variable had to be converted to a string value. This is because each element in the sequence is a list type, and it's not possible to add these two different data types together. Pay attention to line 6 on the top example and line 6 on the bottom example. Line 6 on the top example has a print statement that's not part of the for suite. On the bottom example, the print statement is part of the for suite. Now, even though line 6 is not part of the for suite on the top example, that print function does contain information related to what the for suite was executing. Now, in the bottom example, line 6, you have the print statement indented, making it part of the for suite, and that's why the output between the two examples are coming out a little bit different. On the bottom for statement, what's happening is that print function is executing every time there's an iteration. And if you count the number of lines there are being iterated on, is how many elements or how many items that sequence type has. Let's take a look at a while statement, which is similar to a for statement because it does iterations. The while statement works similar to the for statement. Here's an example of how the general syntax would look like. The header contains a condition, and if that condition is true, the suite will execute. But if that condition is false, then the else clause will execute. The while statement will continue to repeat until the condition in the while header is false. Let's take a look at an example of a while statement that involves registration enrollment. In line 1, the enrollment variable is defined and initialized to 0. Then in line 3, the while clause is stated along with its condition that evaluates the value in enrollment. Since enrollment is 0 and it's less than 5, the suite in line 4 and 5 will be executed. The program does not go to line 6 yet, but instead it will go back to line 3 and go through another iteration. At this point, the enrollment contains the value 1 since this value was added to enrollment. The iterator jumps back to line 3 to check the condition, and the cycle repeats until 5 enrollments occur. This is when the else clause is executed that outputs registration closed, along with the total enrolled. Okay, now that we have some exposure of the different statement types, let's take a look at how these different statement types can be combined together. It is possible to use the control statements together. Here's an example of if-else statements within a for statement. Line 1 defines a list variable containing a sequence of grades. Line 2 is a for statement clause where the header is going to iterate on the final grades variable. Line 3 is the for statement body, also known as a suite, which contains the if statement. Each grade will be evaluated based on the condition in the if header. So if the grade is at least a 73, then the program will print the word pass, and if it isn't, then it will print the word fail. The next example uses the if-elif else statement inside the suite of a for statement. Line 1 defines the letter grade variable, which is initialized to a list data type. The list is empty right now, but elements will be added to this list based on the conditions in the code below. Line 3 is the for statement, which will iterate on the final grades list, which contains 6 grades. Depending on what the grade is, it will be added to the letter grade list using the append method. Once every grade has been iterated on, line 14 will display the letter grade list. This print statement is not part of the for suite, nor is it part of the if-elif else suite. It is simply a print statement that will display the information that occurred inside the suite above. We can add to the previous example by using a nested if statement. Let's take a look at lines 4 through 9. Line 4 begins an if statement with a condition greater than or equal to 90. Line 5 consists of another if statement in the suite of the first if statement. This is called a nested if statement. This second if statement checks to see that a grade that happens to be 90 or greater will also be greater than 97, and if it is, then it will add an A+ letter to the letter grades list. Line 7 contains the else clause for the nested if. The else suite contains the word continue, a Python keyword. This tells the program not to modify anything in this iteration in the nested if statement and to continue to the next statement in the program. Okay, here's one more example before concluding this video. This is a for statement that involves a course variable that consists of a list of values. The list contains a mix of strings and integers. So using the join method on the list will not work. If you have not come across the join method before, this is a way to combine a list of string values together. However, each value or element inside the list must be a string type, otherwise the join method will not work. One solution is to use a for statement to convert each value in a list to a string value. The code in line 4 shows the append method used to add the string values to the list. Inside the append method, the str function is used to convert the value to a string before it is included in the list variable named course_str. Line 5 displays the new list containing all string values, and line 6 displays the list using the join method that converts the list to a string. This code is definitely a lot to take in right now, so it will be a great idea to copy this code in your editor and study it one line at a time.